Exercise 6.2, question number 7. Using theorem 6.1, that is BPT, Thales theorem. Using theorem 6.1, prove that a line drawn through the midpoint of one side of a triangle parallel to another side bisects the third side. Now, after listening this statement, do you recall something? This we have studied in class 9th also. This was the second statement of midpoint theorem. Okay. So once again, in this class also we are going to prove the midpoint theorem, but this time we have to use the basic proportionality theorem to prove the midpoint theorem. Okay. So for this thing, we will draw a triangle. Any triangle we can draw. Let this triangle be ABC, and as we are given that a line drawn through the midpoint of one side of a triangle, so let us take AB as a side and D is the midpoint of AB, and using this midpoint we will draw a line parallel to another side. So from D we will draw a line which is parallel to BC. Now this line from D, let it is intersecting AC at the point E. So what we are given, that D is the midpoint of AB, DE is parallel to BC, and we have to prove that this DE is bisecting AC, that is E is the midpoint of AC. So given triangle ABC, D is the midpoint of AB and DE is parallel to BC. To prove that E is midpoint of AC, that is AE is equal to EC. So either you can write this statement or you can write simply this. So you must remember that in 9th class when we proved this theorem we did some construction, but here construction is not required. We will only use the basic proportionality theorem, and for that sufficient hints are available here. So in triangle ABC we have DE is parallel to BC and by theorem 6.1, which is Thales theorem BPT, we know that a line drawn parallel to one side of a triangle to intersect other two sides in distinct points, then other two sides are divided in the same ratio. So if DE is parallel to BC, then AD upon DB is equal to AE upon EC. But we are given that AD is equal to DB. AD is equal to DB. It is given that D is the midpoint of AB. That means AD upon DB will be equal to 1, as they both will cancel each other. This means that AE upon EC which is equal to 1. This means that AE is equal to EC if we cross multiply here. So here we proved that AE is equal to EC. That means E is the midpoint of AC.